Hello folks, welcome to Cyberblocks. Today we are going to see the blockchain demo. We are going to see the blockchain in very visual way, which will make easy to understand what is blockchain and what are the key pieces of the blockchain. So let's get started with the video. With the help of this website, we are going to see the blockchain in action in a visual way. So I'll provide this link in the description. You can just access through there. So let us see. Before going to understand what is a blockchain in demo, there is something which we need to understand what is a SHA-256 and its hash. This thing, whatever you are looking in here now, this is a hash. Hash is an alphanumeric character. That means it consists of alphabets and numeric. And the alphabets which are there in this are small alphabets, not the capital ones, and numbers from 0 to 9. And this hash, whatever you are seeing here, is a digital fingerprint of some data. Particularly saying whatever the data that I'm going to type in this box, this hash is a digital fingerprint of that particular data. Suppose if I write here cyber blocks. So this data, if you have noticed, this hash has been changed to something else. Like it is starting from 831.9 and ending with 652. So this hash is a digital fingerprint of the word cyber blocks. It doesn't matter how many times we are going to type this, we are going to type this cyber blocks in this, it is going to give the same output or the same hash which is given here. So if I give multiple times, like if I'm trying on a multiple systems or any other way with a SHA-256 and I'm giving the data as cyber blocks, so it is going to produce the same output. It doesn't matter how many times I'm trying to, generate the hash. So for the same identical data, it is going to produce the same output or the hash. So let's copy this text here and remove it, type it again, or let me paste it directly. I'm pasting the cyber blocks. So see, if you see this, it is same hash which was previously there. I can type here a bunch of things. Like it is not only the some words or some character. We can give lots of data in this. I'm just typing the random things. We can paste entire library, and for that data, it is going to generate a hash. And one of the interesting thing about this hash is the length of the data which I'm providing doesn't matter. It might be a single character or a double character or it's a few words or few sentences or entire data of the library. It is going to generate a hash of the same length. What I mean is whatever the hash which is generated, the length of that hash is going to be same, which is 64 bits character for the algorithm SHA-256. So if you see this, this you can assume it as a hash for nothing. Like I have no data in this thing. So this can be the hash for nothing. So even if I write a space, if you see, I'm giving cyber. Oh, sorry. Cyber, and the hash which is generated is starting from F729 and ending with 936. If I give a space, look at this. If I'm giving just a space, the entire hash has been changed. It is now starting with 5833 and ending with 195. So even the space is considered as a data. So even for a small changes, it is going to give an entirely different hash. So if you want to get a same hash, you have to provide the same input of the data. Suppose I came here and gave the cyberspace blocks. It has generated a hash which starts with 576 and ending with 522. And if I come here, back here and give the same data, it is going to generate the same output. And even if there is a slightest change in the data, say in place of Z, I'm giving S, the hash of this thing is going to entirely change. So to get the same hash, we have to provide the same bit of data. Now we are going to extend this idea of hash to something which is called a block. Let us see what is a block. So this is a block. If you see this, it is exactly like a hash. The only difference is that the data part which was there is now divided into three parts. One is block, nouns, and data. So what is this block represents? This block represents the number of that particular or the index of that particular block in the blockchain. So this supposed to be the first block in the blockchain. And what is the nouns? This is the short form of number used only once. This is a number which the miner intend to find in order to achieve the consensus or successfully mine a block. And this is the data part which we have seen earlier. It is same as usual. And if you see this hash, it is something different from the previous one. And what is the difference? This hash, which is the hash of this entire data, which is present above, which includes block, nouns, and data, it is starting from like the starting. If you see the starting of this hash, it is something different from the previously, which is four leading zeros, which is so unusual. Like in previously we never got this one, and it is so unusual, like very less probability of getting this thing, like the hash starting with four zeros. Because it is starting, the hash is starting with four zeros, it is totally arbitrary that I'm going to call this block is signed block or a block valid block. When I change the field, any field above here in this data or nouns or block, if you see the hash is going to change. And what is the probability of that whatever the hash which is generated is going to start with the four leading zeros? It has very less and less probability. Let's change one of the data. Let me change the data field here. I'll make it to high. If you see that when I've changed the data field, the entire block which was in green color has now turned into red, and the hash which is here, it is not starting with four leading zeros. And this represents that the block is not a valid block or it is signed. This is where the nouns come into the picture. We are going to change the value of this nouns so that whatever the hash which is going to hashed out from this data, that starts with the four leading zeros. Now let me change this one to 1. So it is starting with 339. No, I'll append it to 2. Even it is not starting with four zeros. Let me append it to 3. Let me 6. I can keep on doing this until I get the hash which is starting with the four leading zeros. And like this might take a very long time, or like it is very impossible. It is not impossible, it is very difficult to find the hash for this particular data which is starting with four leading zeros. So for that we have a button here which is mine, which is going to guess, like starts with a 1 0, and it is going to count till like until this hash is starting with 0. Let me click on this button. It is calculating. So it found, like for the nouns number 45309, the hash for this data is this one, which is starting from four zeros. So this work, the whatever I clicked and find the correct nouns for this data to be mined, to this block to be mined, is going to done by the miners. Miners are going to guess the data, I mean sorry, guess the nouns value for that particular block, so that this hash starts with four zeros is satisfied, and this block which will make this block as a valid block. So this is the block. Now let us see what is a blockchain. The word itself represent what is a blockchain. Like it is a chain of these blocks. A chain of blocks is known as blockchain. Let us see. If you click on this one blockchain, you will see this is a blockchain. The chain of blocks. Whatever the block that we have seen, it is same blocks, but it consists of many multiple blocks. In this blockchain, we have five blocks. You can see there are five blocks. Which is starting from the first block and then second block and up to fifth block. If you notice, there is another thing has been which is being added to this one, which is a previous block, previous. And this previous is nothing but, if you see this hash, whatever this hash is there, it is starting with three or four zeros and 1578, and this is the same number as this one. And if you see the further in the chain, this number, what is the whatever this previous hash is there, which is four zeros and AE8 double B, is this hash, and it is same for the other one as well. This previous hash is the same as this one. So what does this mean? Every block is going to store two types of hashes. One hash is the hash of its own data, which represents this entire thing, block nouns data, and also the previous hash. So this hash is a hash of this entire data, this entire thing, including the previous hash. And along with its own hash, it is going to store another hash, which is previous hash. This is how they are, the blocks are connected with the previous one. If you see, this one matches with this one, and this one is going to match with this one, and so on. This is how a blockchain is formed. When you come to the first block in the blockchain, which is also known as the Genesis block, the first block in the blockchain is known as a Genesis block. There is no blocks, like before this block there were no blocks, so all the characters in the previous hash will be zeros. It is a dummy data because it doesn't have any previous block before this, and this is a first block in the blockchain. It will not have a previous hash. So what will happen? Let's see how it works here. If I'm going and changing some data here, let's say put cyber blocks. As we have seen in the block section, it is also like when I'm changing this any data here, the hash of that one is being changed, and we can see that the hash which is generated is not a, it is not starting with four leading zeros. So we can say that this block is not at the valid block, and it doesn't have a valid fingerprint. So to make this a valid block, or which has a valid fingerprint, we can just go and mine this block. See, it has generated a hash which is starting with four leading zeros for this entire data. Let's remove this one for now. Okay, and what happens if I change the data in say block number 3? I'm giving high. So if you see this, it is going to break all the blocks which are succeeding to it. Why is that? Because whatever the hash we have here is being to copy to next one. If you see this, so if this block is broken, then all the other blocks which are succeeding to it will be break, or will not be a valid one. So for that, what we can do is we can just mine this block, and this block to make a single change in a block, in the previous block, whatever in the middle of block or wherever in a block, we have to mine all the succeeding blocks as well. So adding a data in the last block of the blockchain is very easy when compared to the previous one. Like if you're adding some data here, you have to mine all the succeeding blocks as well. And just if you want to add some data in the last block, you need to just find the correct nouns or mine this one particular block itself, not the others. So how we can know that whether the block has been tampered, I mean changed, the data has been changed, or it has been remined or not? We can know this using distributed blockchain. We'll see what is distributed blockchain now. So let's see a distributed blockchain. If you see this, There is peer 1, peer A, peer B, and peer C. You can think of this peer A, peer B, and peer C as a nodes, different nodes in a blockchain. Remember in my previous video, I have thought that blockchain consists of a different there are number of nodes connected to each other which has the same copy of blockchain. So we can say that peer A, peer B, peer C has the same copy of the blockchain. If you see, there are five blocks in with each peer. Here the peer B, sorry, peer B also has a five blocks in a blockchain, and as well as peer C. And if you look at the hashes of this one ends with like E4B. This one also ends with E4B. This one also ends with E4B. So what I'm going to do is now I'm going to change some data in here in the peer one's blockchain. I'm in the block number 3. I'm going to change some data and put it as cyber CKZ. See, if I'm changing this data in the block number 3, it is going to break all the other blocks in that blockchain. So what I will do is I'll mine this one. So the to get the nonce which gives the hash which has the 4 leading zeros, and then we'll mine this block as well. We'll mine this block as well. Now we see that all the blocks are in green color, like no block is a invalid block or invalid block. But if you look at this, the hash of the last block is like starting with four leading, even though it is starting with four leading zeros, it has hash as 1A212. But if you look at the other blocks, I mean the other peers, other nodes in the other nodes, they have the last block whose hash is like it is starting with four zeros and EB E4B, sorry, E4B9, and the last one is also E4B9. So it is very clear that there is some tampering or change in the data has been happened in the first one, because other two, like the majority of them have the same hash in the last block, which is 4B9, which is 4B9 here as well in the peer 2, but this one has D09. As the majority of the nodes has the last hash of the block is which is 4B9, and only this peer has the last block whose hash is D09, like it is after four leading zeros it has D09. It is a odd one out. So we are going to consider these two, this one which have like majority of them have. So like this we can find out if there is any tampering or like the data has been changed or not in any of the chains. In this blockchain we have only five blocks, but in a real world blockchain we might have like lots of number of blocks. So we cannot just go and compare all we need not to go and compare all the data whether it is same or not. We can just come here and see the last hash of the last block's hash. If it is same with the others one, then we can say all the data is there is no tampering with the data, or all the blocks this blockchain is also valid, we can say that. So if you see this now, I'm just showing in the data section I'm typing cyberblocks or hi or something like that. It is very odd. Let's put some like data, the real world transactions in this one, or the tokens kind of thing. Let us see that example. So let's see these examples with some of the transactions in the data field. It is just arbitrary values. And so if you see that in the first block, like this consists of some transactions, and in the place of data we have replaced it with some of the transactions, and second one also has some of the transactions. It is a little bit more than others, so it doesn't matter how many transactions are there. There are no transactions in the block. If you see, uh, this is the last block has a hash of 1DA, and in this one peer 2 as well, it has the same 1DA. So it is the same copy of, like, these three are the same copies of a single blockchain. If I'm going and modifying something here, so if you see that there is $25 from Rajesh to Pranay. If I'm going and modifying this to $250, the entire chain is going to break. It is same like usually when we saw the distributed blockchain, it is working in the same way. So it is very important to keep track of the all the transactions which happened, and we it may blockchain make sure that there is no tampering with the data with as it has the same copy of the blockchain with other peers as well. Like there are many nodes which are known to be peers as the of the blockchain, who consist of the entire copy of that blockchain. There is one thing that I need to tell. In this transaction, if you see, we are saying that Rajesh is sending $25 to Pranay, and we are not checking anything. Like we are not checking that Rajesh whether has $25 in his wallet to send to Pranay or not. So what happens is initially there is a check before adding this transaction into the block. There is going to be a check which will happen, that will check whether Rajesh first has $25 in his wallet or not. If he has, then only this transaction will be added in this block. Until or unless that will not add, because there might be some tamperers, like just these transactions are added in the block by the miners, right? So miners themselves can add some transactions and do a tampering, right? So before adding the transaction in the block, there will one check will be happening whether this person, whoever is sending this amount to someone, is having that amount in his wallet or not. And it is verified, and that block, whenever a block is mined or at all the transactions or data is added to a blockchain, I mean a block is added to blockchain, whatever the data is present in that block, I mean these transactions, it is not only like verified by that the person who have added to that one, but also by the others. For this, there are mining and all, there is a I'll create a dedicated video for that, how the transactions and other things are verified before adding to the blockchain and all. So that's it for this video. For more such interesting topics, stay connected with the cyberblocks, and please do not forget to like and subscribe. Thank you.